Welcome fellow learners. In this video, we will be testing code generation using the recently released open source model Codestral Mamba. It is being provided by Mr. AI. This model specializes in code generation and we will be running it in free Google Colab version. Now let's talk about the architecture. This model is based on Mamba models which operate on state space model concept. There are two major benefits of Mamba models over transformer models. The first one is Mamba models have linear inference time while transformer models take subquadratic time for inference. Second one is Mamba models have the theoretical ability to handle sequences of infinite length. With Mamba, you can engage with the model extensively and get quick responses regardless of the input length. So enough with the theory, let's jump into the implementation part. So in your Google Colab notebook, we need to first connect to a GPU. So to connect to a GPU, click on this runtime, then click on this change runtime type, and then select this T4 GPU. This is our free GPU available in this Google Colab. Then click on this save and then connect to this T4 GPU. Once we have connected to this T4 GPU, we need to first install few required libraries. These are the libraries that we need to install. So let's run this cell. The first library is Mamba SSM. This is the core library that will be required in Mamba architecture. The second library is Causal Con 1D. This is a simple convolutional 1D layer that will be required for the Mamba state space model. The third library is Mistral Inference. So if you go to this page of Codestral Mamba of this Hugging Face, you will find out they recommend to use Mistral Inference to perform inference through this Codestral Mamba. For that part, we are going to install this library also. So let's wait for a while. Now, as all the required libraries are being installed, in the next step, we need to authenticate this notebook using our Hugging Face token. To get the Hugging Face token, you can go to this Hugging Face web page, then click on this user icon, and then click on this setting button. Once you get there, you need to click on this access token and you can create your access token over here. So click on this create new token and then select this read tab and then you can name your token. So like I will be naming this Codestral Mamba and then you can click on this create token. Here you can copy this token and we will be utilizing this token to log into this Hugging Face hub in this particular Google Colab notebook. So let's click on this cell and then run this notebook login. It will ask to enter a token. So let's paste that token over here and then click on this login button. Now you can see that login has been successful. One other thing that we need over here is we need to get access of that particular repo, that Codestral Mamba. So if you see that Codestral Mamba, I have already been granted access. So you can see you have been granted access to this model. But in your case, let me give you an overview how to access this particular repo. If we see any other Codestral web page, so you can see in this type of dialog box will be shown to you, like you need to agree to share your contact information to access this model. Then you can click on this agree and access repository and you will be granted access to that repository. Once you have done that, you can access this Codestral Mamba model in this particular Google Colab notebook. Now in the next step, we are going to download this Codestral Mamba model. First, I will be creating a folder where I will be downloading this Codestral Mamba model. So I will be creating this Mamba Codestral folder under this Mistral models folder. So let's run this cell. And if we go over here, this folder would be created, this Mamba Codestral. Once it has been done, we are going to utilize this snapshot download module from this Hugging Face hub to download this particular Codestral Mamba model. You can see I am passing this path, this folder path that we have just created. So these are the three arguments that we are going to pass to this snapshot download module. The first one is repo ID. You can get your repo ID from this Codestral Mamba page. So if we see this particular, we can copy this one and we can utilize it over here as repo ID. The second one is allow patterns. So these are the files that we need to download. So if you go to this Hugging Face page and click on this files tab, you will be seeing the different files that are available in this Codestral Mamba model. So these git attributes and readme.md are not required. we are going to require only these three files: consolidated safe tensors, params.json, and tokenizer.model.v3. So for that part, we are going to pass this in allow patterns. And the third argument is local dir. This is the path where we are going to download this model. So let's run this cell, and it will download this model in the specified directory. So if you see, there might be two files already being downloaded, this params.json and tokenizer.model.v3, because these are having very less memory size. The third one is this consolidated.safe tensor. You can see this is having of size around 14.6 GB, and that's why it will take a little time. Now this model has been downloaded. So if we refresh over here, it will show us all the files that has been downloaded over here. So we have our this Codestral Mamba model. In the next step, we are going to run this Codestral Mamba model in this particular notebook. So if you go over this Codestral Mamba Hugging Face page, they have given a CLI command through which we can run this model. But if you remember, when we used to use auto model for causal LM or auto model from Hugging Face, we need not to use any command line command to run inference of those models. But here we need to use this Mistral inference, and through that we can use Mistral chat command to do inference for this particular model. So we are going to do the same in this particular Colab notebook. The problem is we cannot use the terminal in free version of this Google Colab. For that part, we are going to install this Colab XTerm library. This will be utilized to run a terminal in a cell. So we are going to first install this library, and then in the second step, we are going to load that Colab XTerm in this particular notebook. Once it has been loaded and installed, we can run this cell XTerm, this particular %XTerm, and it will open a terminal in the same cell over here. So you can see it is launching. So you can see it is launching XTerm, and now it has opened a terminal in this particular notebook. Now we can use that command, that CLI command using that Mistral chat to run this Codestral Mamba model. For that part, let's first go to that Mistral folder that we have created earlier, and then we can run that command. As we have installed that Mistral inference library, this Mistral chat command will be available in this particular environment. So we can use that. Then we can pass the folder name where we have downloaded that Codestral Mamba model. So we have created that Mamba folder. So we can pass that name. And then we need to pass this instruct argument. Then finally we can pass the argument max tokens, the total maximum number of tokens that we want this Codestral Mamba model to predict. So let's say at the start we pass 256 token, and now we can run this command to see how this particular Codestral Mamba model works. Now if you see, the size of this Codestral Mamba model is 14.6 GB. So let's see how much GPU it is utilizing. So if you see, this GPU RAM is getting increased as for the utilization part. Like you can see, it is now 7.1. Once it has loaded the complete this Codestral Mamba model, it will provide us a prompt where we can enter our query, and then we can run this model. So let's wait for a while. So it has loaded this model, and it has provided a prompt where we can enter our query. So let's just enter a simple query hi and pass it to this Codestral Mamba model, and let's see how does this response. So if we see, there is an error like feature B float 16 requires target SM80 or higher. So the problem is with this GPU that we are using. So if you see, we have selected this T4 GPU as it is only GPU that is available in free tier of this Google Colab. So that is causing the problem, because bfloat 16 type of parameters cannot be run in this T4 GPU. So what we can do, we can load the model in a float 16 format. So for that part, as we are using this Mistral inference library, we can go to the installed folder of this Mistral inference library, and then while loading the model, we can pass an argument d type = float 16. So let's do that. So let's go to that folder. we can find that library in user folder of this collab. So we can go to that user, and then we can go to this local, and then here we can find out this lib, and then we can see this Python 3.10 is being there. So here we can find in this dist packages all the packages that are being installed in this particular Python environment. So we need to find out this Mistral inference package, and then we can make the changes that we need to do over here. So we can go to that. We need to scroll a little. So here we can see Mistral inference package is there. Now in its main.py file, we can make those changes. Instead of passing that b float16, we can pass the argument of float16. So we can go to this interactive function. Now here you can see this model is being loaded from the folder, that snapshot that we have downloaded from Hugging Face. Now over here we can pass dtype argument equals to torch dot float16. In this way, the model will not initialize the parameters in bfloat16. Instead, it will initialize the parameters in float16 format. So let's save this file. Once this file has been saved, we need to restart this notebook. So let's restart it. Now this notebook has been restarted. So let's again run that terminal. So as we have already downloaded that model, we need not to download it again. The only thing is we need to load this Colab xterm for the terminal part, and then we can run this xterm terminal over here. Now we will again do the same thing. We will first change the directory to that folder that we have created, that Mistral folder. Once we are into that directory, we can run that Mistral chat command. So we can do Mistral -chat, and then we can pass the folder name where we have downloaded that model, that Mamba folder name, and then we can pass that instruct argument, and finally we can pass the max number of tokens that we want this model to generate. So let's say at the start we pass only 256 tokens. Now let's run this command and let's see will it be able to run this model in this notebook or not. So let's wait for a while. We can also see the resource utilized by this model. Now you will see the VRAM utilized by this model will keep increasing until this model is fully loaded. So now the model has been initialized in this notebook. So let's pass a simple prompt to it. Let's say hi, and let's see how does this model respond back. So great, we can see it has provided us the response like, hello, how can I help you today? So it has utilized around 14.7 GB of this GPU, which is neck to neck, as it is only 15 GB of RAM available. So, but we are clearly able to run this Codestral Mamba model in free GPU tier of this Google Colab. So let's ask a question related to coding. I will be asking it to provide an algorithm for edit distance. So I will be asking it to provide in Python, provide edit distance algorithm in Python, and let's wait for a while and see will it give the correct answer or not. So great, we can see it has provided us the result, and if you try it out, you must be seeing this model is providing us the result in very quick time. Like if you use any other transformer based model which are having a size of around 14 GB, utilizing 14 GB GPU, will not be able to provide the result in this fast speed. Now let's copy this code and run it in this notebook so that we can see if it is working correctly or not. So let's copy and paste it over here, and let's pass any two string to see if it is giving us the correct edit distance value or not. So let's first pass to same string, so like hi and again hi. So let's see what does it provide to us. We can see it is providing us the correct result like 0. Let's pass a different string to it like hi there. So let's see how much edit distance it provides to us. So like you can see it is providing us 6, 5 for these words and 1 for this one. So great, we can see it is working correctly. Now you can try it out. You can pass different prompt to it and ask different questions related to coding, as it is specifically trained for code generation. And if you try it out, you will clearly see it is giving us results much faster than the same size transformer models, like any transformer model like DeepSeek Coder V2. You will see this Codestral Mamba model provide results in much faster way. So great, test it out and you can use it while doing coding, and you can use it as your coding assistant. It will be really great help whenever you are coding and utilizing this Codestral Mamba model. As we can see, we can run it in this free GPU tier version of this Google Colab. So we need not to pay any price to use this Codestral Mamba model. So great. Thanks for making till the end of this video. Goodbye until the next time.